Okay, so in this video we're going to be covering fluency in solving linear equations. So let's look at our first example. Here we're going to distribute the 4 on the left hand side. So this becomes 4/3 minus 4x is equal to 4/5 plus 16x. Now here, if we wish to get rid of the fractions, we can just multiply the whole entire equation by the LCD of 15. So for the first term, 15 times 4/3, you can multiply 15 times 4, that gives us 60, and then divide by 3, and that would give us 20. Or you could have said 3 divided into 15 is 5, and then 5 times 4 is 20. Then we have 4 times 15 is 60, 60x. 5 divided into 15 3 times. 3 times 4 is 12. And then 15 times 16. Well, 16 times 5 is 80. And then you do 16 times 1. So you have 16 times 5 would be 80. And then 16 times 1 would be 16. And if we combine that together, it gives us 240. So that'd be 240x. Now, subtract 12 from both sides, we're going to get 8. And now we want to, no, this 12 is no longer there because we subtracted it from both sides. Now we're going to add 60 to both sides, so we're going to get 8 equal to 300x. Okay, so we added 60x to both sides. And so we have 8, and now we divide both sides by 300. Now divide both the numerator and denominator by 2. That would give us 4 over 150. And then if we again divide by 2, we get 2 over 75. So x is equal to 2 over 75. Okay, there's another way of doing this. By if we, rather than distributing first, if we factor the right-hand side instead, then we could factor out 4 on the right-hand side. That'll leave 1/5 plus 4x. And now divide both sides by 4. So we have 1/3 minus x is equal to 1/5 plus 4x. Now multiply by the LCD of 15 again. Multiply by LCD of 15, so 3 into 15 goes 5 times. Then we'll have 15x. 5 goes into 15 3 times. And then 4 times 15 is 60x. Now subtract 3 from both sides, we're going to get 2 minus 15x is equal to 60x. And then add 15 to both sides, so 2 is equal to 75x. Divide both sides by 75. So x is equal to 2 over 75. Okay, let's look at our next example. So here again, we could use distributive property on both sides. Okay, so using distributive property, we'll have 3 distributed on the left and a minus 4 distributed on the right. So this becomes minus 12x, but here negative and negative would be plus. And then 3 times 2.8, 3 times 8 is 24. So bring down the 4. 3 times 2 is 6. 6 and 2 is 8. So 8, put back in our decimal point, 8.4. On the right hand side we have minus 16x plus. And then we have 4 times 8 is 32. 4 times 2 is 8. 8 and 3 is 11. put back in the decimal point. And here we can subtract 8.4 from both sides. And so we have minus 12x equal minus 16x plus 2.8. So now we can add 16x to both sides. So we get 4x is equal to 2.8. Divide both sides by 4, so we get x is equal to 0.7. Okay, we can do this also in a different way. So now if we look at this equation, if we observe that these two amounts that are in the parentheses, they're both the same, right? This and this is the same. So in other words, this is saying minus 3 times some amount is equal to minus 4 times the same amount. Well, that could only be true if a is equal to 0, if that amount is equal to 0. Well, that amount happened to be 4x minus 2.8. So if that's equal to 0, adding 2.8 to both sides, we get 4x equal to 2.8, and divide both sides by 4. So x is equal to 0.7. Okay, let's look at our next example. So here we have two unknowns and we have two equations. So I wish to solve this by using the addition method. So I'm going to use the addition method. In the addition method, I want it in this form: ax plus by equal to c, where a, b, and c are constants. So in the first equation, I can just subtract 6y from both sides. So minus 4x minus 6y is equal to 2. So now that first equation is in the form I want it to be, ax plus by equal to c. And now this second equation, use distributive property first to get 6y minus 15 is equal to 5x plus 1. Add 15 to both sides. So we get 5x plus 16. And now subtract 5x from both sides, right? But I want the x to come first. So minus 5x plus 6y equal to 16. Now, to get rid of one in the unknowns, I need them to be the same amount but opposite in sign. So if I observe the y's in the first equation and the y in the second equation, they're both the same amount and opposite in sign. So I don't have to do any manipulation. I can just bring the first equation down. Minus 4x minus 6y equal to 2. Now add down vertically, the y's cancel out, and I get minus 9x is equal to 18. Divide both sides by minus 9. So x is equal to minus 2. So with that information, I could plug it into the first equation. Minus 4 times minus 2 is equal to 6y plus 2. So here I get plus 8. Plus 8 is equal to 6y plus 2. Subtract 2 from both sides. Subtract 2 from both sides, so I get 6 equal to 6y. Divide by 6. So here, y is equal to 1. So now they want us to solve for xy. So remember that x value comes first all the time. So we want the x value coming first, minus 2, then the y value. So here. All right, so let's look at our last example. So here, again, we could do it like we did before. We want it in the form ax plus by equal to c, where a, b, and c are constants. So the first equation, I can just move the 10y over by subtracting 10y from both sides. So I get minus 5x minus 10y equal to minus 5. Well, here I see that everything is divisible by 5, so I'm going to divide the whole equation by 5. And so this becomes minus x minus 2y is equal to minus 1. Now the second equation, I'm going to distribute out on the left-hand side, so that becomes 6y minus 3 equal to minus 2x plus 3. Add 3 to both sides, so we get 6y equal to minus 2x plus 6. And now add 2x to both sides, so I get 2x, and that's a plus 2x plus 6y equal to 6. Again here, everything is divisible by 2, so might as well divide by 2. So x plus 3y is equal to 3. Now, once again, if we look now here, the amounts for the x, so that's minus 1x in the first equation and plus 1x in the second equation. So they're equal amounts and opposite in sign. So just writing that first equation, bringing that first equation down, writing it underneath the second equation. So minus x minus 2y is equal to negative 1. So here, these two cancel out. We're left with 1y, and y is equal to 2. Well, now that we know that y is equal to 2, we can go to the first equation. So coming up here, we'll have minus 5x equal to 10 times 2 minus 5. So minus 5x is equal to 20 minus 5 minus 5x is equal to 15. Divide both sides by minus 5. So x becomes minus 3. So in coordinate form, x value always comes first, so minus 3, comma 2. Okay, and as a matter of fact, there's another way of solving this equation, so let's look at that. And this is a faster way, so let's look at it. So observe if from the very beginning, before I move the 10y over, if I divided everything by plus 5, so that would become minus x equal to 2y minus 1. Well, here's our second equation. 3 times 2y minus 1 equal to minus 2x plus 3. Well, look at this amount. This amount, 2y minus 1. 2y minus 1 is the same thing here. So I could substitute. I'm going to substitute minus x for 2y minus 1, because 2y minus 1 is equal to minus x. So 3 times minus x is equal to minus 2x plus 3. So we have minus 3x equal to minus 2x plus 3. Add 2x to both sides, so we get minus x equal to plus 3. Divide both sides by negative 1, so we have x equal to minus 3. And then we substitute into the first equation like we did before. So we have minus 5 times minus 3 equal to 10y minus 5. So negative and negative, so that's plus 15 is equal to 10y minus 5. Add 5 to both sides, we get 20 is equal to 10y. Divide both sides by 10, so y is equal to 2. So again, we have our x value and our y value. So x value comes first, so minus 3, comma 2. Okay, that's it for this video. Thank you for watching.